Today we are solving multi-step linear inequalities. The good news for you is you solve inequalities the exact same way as you solve equations, with one exception. If you multiply or divide by a negative, you flip the sign. So that's the only big thing I need you to remember. Otherwise, we're still going to use this acronym, right? Don't call me after midnight. Distribute, combine like terms, move your variables to one side, add or subtract, multiply or divide. Same process, just be careful if you multiply or divide by a negative. Okay, we're also talking about special cases, so you're infinite and no solutions today. Let's look at example 1. First thing, do you see, so D is for distribution. Do you see distribution? Yep, it is right here. So I'm going to distribute, and let's write that step. I get 6a. 3 times -1 is -3. Keep that inequality sign. Please be careful that you don't switch it out for an equal sign. I see that a lot. And then bring down the right side. Next step is C. Can you combine like terms? And this is where I'd yell at you in class. No, you can't, because your, quote, like terms are on different sides. So they are actually not like terms. But you can move your variables to one side since you have variables on both sides. Okay, let's do that. You can move the 6a or the 10a, it doesn't matter. I'm going to move the 10a. So I will subtract it because it's positive and I'm moving the whole thing. That's gone now. So my new equation should say -4a. Some of us need to start using a calculator to check our work when we're subtracting, especially when it involves negatives. And that's equal to, not equal, greater than or equal to -11. Next step, add or subtract. In our case, we are going to add 3 because it's subtracted. So that we get -4a is greater than or equal to -8. Last step, M, which stands for multiply or divide. And we are going to divide by -4. I see some of you who are, you see something like this, -4a, and you are adding 4. That's incorrect. This is multiplication, so to undo it, you divide. You have just divided by a negative, and so you have to flip the sign. Don't forget, a is now less than or equal to +2. Let's go ahead and graph it on a number line. So I've got 1, 2, 3. It's less than or equal to 2, so I'm going to have a solid circle, and it goes less than, which goes down. Example 2. Same process, don't call me after midnight. First thing I check for is distribution. I don't have any, so then I check, can I combine like terms? No, I can't. They're on different sides. Do I need to move my variables to one side? Well, yes, I do, because I have variables on both sides, and we do not like that. Let's go ahead and move them. Let's move the 3x. It's positive, so I will subtract it so that my new equation is now 2x minus 12 is less than or equal to -4. All right, we've moved our variables. Now we will add or subtract. This is subtraction right here. So we are going to add 12 to both sides, and that cancels out. So So I get 2x is still less than or equal to -4 plus 12. Use a calculator if you have to. I want you to get it right. Positive 8. You divide by 2, because this is multiplication, you should get x is less than or equal to positive 4. It says solve and graph, so let's graph it. We're at 4. Let's get two numbers surrounding it, 3 and 5. Less than or equal to should be a solid circle. And since it's less than, it's going down. Onto the back, we're talking about special cases of inequalities. This is the same kind of thing as when we had equations. If you get something at the end, if it's true, like does it work? So something, let's say like this, 3 is less than 5. That's true. I tried to make a check mark, it's not working. There we go. 3 is less than 5. Another example would be like 2 is greater than or equal to 2. 2 isn't greater than, but it is equal to because it's greater than or equal to. So these things are true. Then you would say either identity, infinite solutions, or like we talked about the other day, you could also say all real numbers. Any one of those three is great. Something is no solutions if it's false. So is it false? So something like 10 is less than 8. No, 10 is not less than 8. So that's false. Another example would be like 5 is greater than or equal to 2. Oh, that's wrong. 5 is greater than or equal to 7. There we go. It's not, and so this is false. So if it's false, then you have to say no solutions. Okay, let's go ahead and solve this one out. It's going to be like the equations where our variables cancel out. First thing, we distribute. So I get 2k minus 10 is less than 2k plus 5. Now, can we combine like terms? Heck no, because they're on different sides. Move on. Can I, or should I move my variables to one side? Yes. Okay. So we move 2k by subtracting it. And look, they both cancel out so that you're left with -10 is less than 5. You need to think for me, is it true or false? Is -10 less than 5? Yes. So you need to say your final answer. Because this is true, I say infinite solutions as my final answer. Okay, on the last one, I've got a typo and this is my fault. So we're gonna fix it right now. I want you to change this out so that it's greater than or equal to. Otherwise, this problem isn't very helpful because we were talking about inequalities today and I put an equal sign. Put a bar down the middle and let's go ahead and distribute so that we get 6x plus 8 is greater than or equal to 6x plus 12. Maybe you can see it already. We'll now move our variables to one side because there's no like terms. Those cancel out. So you're left with 8 is greater than or equal to 12. And check both. Is 8 greater than 12? No. And is 8 equal to 12? No. Neither one of those works, and so you put a slash through your equal sign because it's false, and then you say no solutions, which is your final answer.